Hey kiddos, we've been working the past few days on finding the volume of rectangular prisms. If you remember, volume is the amount of space inside an object or the amount of space an object takes up. So we're going to start transitioning from rectangular prisms to triangular prisms. So the first thing we have to figure out is what is a triangular prism. So remember, prisms are 3D shapes. So specifically, a triangular prism is a 3D shape with triangle bases and rectangular sides. So you'll notice I'm going to kind of shade in those triangular bases. There's one there, there's one at the back, and then we also have our rectangular sides. So I'm going to outline one of our rectangular sides. So pretty similar to a rectangular prism in the fact that there are a lot of rectangles. However, rather than rectangular bases, we now have triangular bases. So the first thing I want us to think a little bit about is what does a triangular prism look like when it's unfolded? So we talked a little bit about nets with rectangular prisms. We're going to look at nets more as we do surface area. So over here, Mrs. Brown gave you a triangular prism. And I gave you three possible nets, three possible unfoldings, if I take that shape apart, of a triangular prism. So it looks like we have a circle and then kind of like a triangle with a rounded bottom. So that's number one. We also have, it looks like 1, 2, 3, 4 triangles making up a net. And then last but not least, it looks like we have 2 triangles and then 1, 2, 3 rectangles also making up a net. So a couple things to think about real quick before we decide which net is the rectangular prism. Let's think about the shapes that we said make up the rectangular prism. So the reminder, the net is the 2D unfolded version. It's like if I took the shape and laid it flat. So let's think about what shapes are going to make it up. Think about the shapes that we shaded in or outlined on that first slide. So we know that a triangular prism should have 2 bases, and they're 2 identical triangles. We can't have 2 different triangles because our shape would not form a triangular prism. We also have 3 sides that are rectangles. So when we look at these nets, we're looking for 2 identical triangles and 3 rectangles. So if we look at net number 1, it looks like we don't have 2 triangles and we don't have any rectangles. So that is not the correct net. The next one, we have lots of identical triangles. However, we don't have any rectangles, so that is not the correct net. And it looks like on our last one, we have 2 identical triangles, and then we have 3 rectangle sides as well. So that last one is the correct net for a triangular prism. So the big thing to think about now is, how do I find the volume? So here's the way that Mrs. Brown likes to think of it. A triangular prism is really like a lot of triangles stacked on top of one another. Kind of think of it like sticky notes. So if we were trying to find the volume of a pad of sticky notes, we could find the area of the bottom sticky note and then multiply by how many sticky notes we have. We can do the exact same thing with a triangular prism. So if you look, Mrs. Brown has outlined or kind of shaded in the triangle that is purple. That represents the bottom base or triangle. This shape is really a bunch of those triangles stacked on top of each other all the way up to form basically a giant stack of triangles. So let's look at how we can use that information to find the volume. So the big thing here, if we find the area of the base, so the triangle, we can multiply by the height of the prism. So let's kind of walk through what that looks like first. One of the biggest things you probably want to think about first is what the formula is for the area of a triangle. So it's either base times height divided by 2 or 1/2 times base times height. Either one, same thing. So let's think about our bottom triangle down here. If we look, remember your base always has to form a right angle with your height. So it looks like the base of our triangle is 8 inches. It looks like the height of our triangle is 3 inches. And then we're going to divide by 2. So we end up with 24 over 2 or 12 inches. So that's the area of this bottom triangle. But remember, think of it like sticky notes. One triangle on top of another triangle on top of another triangle until we build the entire height of this prism. So if you look, the height of the prism is 12 inches. So we can take the area of our bottom triangle and we can multiply by our height of our prism. So we have 12 inches and 12 inches. To find the total volume, so when we do 12 times 12, we get 144. And because it is volume, if you remember from what we practiced with rectangular prisms, it will be cubed, so inches cubed. So let's look at our next one. We're going to follow the exact same principle. So same thing, I left it up there. If we find the area of the base, so if we find the area of the triangle, then we can multiply by the height of the prism. So Mrs. Brown picked this problem just because it has a little bit different placement of the prism. Rather than the prism being on its bases, it's on one of its sides. So first, let's look at the triangle. So it looks like we have a right triangle. And it looks like the base of our triangle, so remember base times height divided by 2. The base is 24, and the height is 7, and then we need to divide by 2. So let's take a second and calculate what that would be. So we have 24 times 7, which gives us 168. And then we have our 2, so we're going to take 168 divided by 2, and we end up with 84 meters. Then we have to think about what's the height of the prism. Remember, think back to what we did here. We had the base, and then we had how tall the prism is. Here it's going to kind of look like how long the prism is. So in this case, our height of our prism is 22 meters. So, excuse me, we're going to take our area of the triangle, our 84, and we're going to take the height of the prism to find our total volume. So we're going to do 84 times 22, and we should end up with 1,848 meters. And don't forget that cubed, meters cubed. Alrighty, let's look at just a couple more. So this one, we have to find the area of the triangle. Once again, use the height and the volume. Mrs. Brown made it a little bit trickier here for us to figure out because there are some extra dimensions. So the first thing is find your triangle. I always, like I said before, like to kind of outline it. It looks like once again we have a right triangle. So remember base times height divided by 2. And it looks like our base of our triangle is 12. Our height of our triangle is 16. One thing to remember here is your height has to form a right angle. So the height is not this 20 centimeters. And then we need to divide by 2. So let's do the math real quick. Looks like 12 times 16 is 192. And then divide by 2, and we end up with 96 centimeters. It looks like the actual height of our prism, so our triangle and stacked on top of one triangle, another triangle, another triangle, another triangle, another triangle, is 10. So the height of the prism is 10 centimeters. Then I'm going to come down and I'm going to take my area of my triangle times the height of my prism, and I end up with 960 centimeters cubed. Alrighty, one more and then we'll look at a word problem. So this one is kind of funky too in how it is laying, but we're going to follow the exact same process. Remember, area of the base times the height of the prism. So the first thing we need to figure out is the base. Well, this one's nice because it's laying on that triangle base, but we have 3 different dimensions. We have 4, we have 6, and we have 7.2. So we need to figure out which dimension that we need to use. Always, always, always remember once again that the base and the height should form a right angle. So it looks like our base in this case is 4. So we have base times height divided by 2. It looks like our height is that 6. And then divided by 2, so 4 times 6 is 24. And then divided by 2, so do 24 divided by 2. You should end up with 12 centimeters. And then we have to think about the height of the whole prism. So remember, we have a triangle stacked on top of a triangle over and over and over again. If we look, 7 2/10 does not give me the height of my prism. It is the other side of the triangle I don't necessarily need. So if you look, 8 centimeters tells me how tall that prism is. So to find the final volume of the prism, we have 12 centimeters times 8 centimeters for a total of 96 centimeters cubed. So remember, base of the triangle times the height of the prism. Then last but not least, we have a little word problem to apply what we've been doing. So this says the base of a triangular door wedge has an area of 55 square centimeters. The height of the wedge is 5 centimeters. Find the volume. So here's what I would encourage you to do and exactly what I'm going to do. I'm going to use the 3 pieces of information we've been using on the above slides. So I need to know the area of the triangle. I need to know the height of the prism, and then I need to find the volume. So the really nice thing about this problem is it already told me that the triangular base has an area of 55 square meters. So here we don't really have to solve anything. We're just going to put that our area is 55 meters squared. Then it says the height of the wedge is 5 centimeters. So it told us the height of our prism is 5. Then last but not least, following that exact same process that we've done the past few times, 55 times 5, and calculate that out, gives me 275 centimeters cubed. So we successfully made it through. If you have any questions, please don't hesitate to reach out to your math teacher. I hope you guys have a wonderful day.